Hi, welcome to the AWS Summit Online for the Americas. My name is Richard Boyd, and today we'll be covering infrastructure as code on AWS. I'm a senior developer advocate for the AWS Code Services, so this includes the code products such as Code Build, Code Pipeline, Code Deploy, Code Artifact, Code Commit, as well as the SDKs, the CDK, the CLIs, basically any tool that developers use to build applications on AWS for services that I'm a developer advocate for. Today we'll cover infrastructure as code, the basics, which is just a quick recap of some of the terminology and the terms we use to describe infrastructure as code and how we think about it. Then we'll cover how specifically AWS handles infrastructure as code with AWS CloudFormation. Next, we'll cover the best practices when using AWS CloudFormation. And finally, we'll wrap it up with a brief discussion of the AWS Cloud Development Kit, or CDK. Let's get into the basics. So when you're managing cloud applications, that involves managing the lifecycle of these resources. By lifecycle, we're talking about creating, updating, deleting these resources. The stability of your workloads often depends on the proper management of these application resource lifecycles. We talk about resources, we're referring to compute resources such as EC2 instances, Fargate cluster, Lambda functions, RDS databases, Kinesis streams, basically anything that you could build inside of AWS could be modeled as a resource. In the example that we have here, we have a VPC that's spread across multiple availability zones to provide high availability, as well as auto-scaling EC2 instances to scale up and down to accommodate peak demand or off-peak demand. So it's also very cost-effective as well as being highly available. So customers don't have to decide, do I want this to be available or do I want it to be cheap? We give you the best of both. These resources are the building blocks or components of cloud applications. You can think of them as the atomic unit of a resource or a cloud application. And there's several options for managing a resource's lifecycle. So the option that's easiest to get started with is the AWS Management Console. We offer a guided experience where you can say, I want to create a new S3 bucket. We'll say, okay, what do you want to name it? Depending on what you name it or where you want to put it or what security settings you say are important to you, we'll give you a few more options. If you decide you don't want the bucket anymore, you can go through this console, see the bucket, remove it. It's very beginner friendly to start doing this when you might not know exactly what it is that you're looking for, so it makes it easier to list items. You might not know exactly what properties you want to apply to it, so we can use some visual techniques in the console to draw your attention to things that may or may not be important, depending on what you've identified. But this doesn't really scale very well. If you want to create hundreds of buckets or you want to create 1,000 users, manually clicking through the console for each action can be very time consuming. So we offer the command line interface, the CLI, and the SDK, the software development kit, to allow you to programmatically interact with your AWS resources. This does require some programming experience to get started. We offer SDKs in Go, Java, PHP, Ruby, and it allows you to programmatically build thousands of resources or tear down an entire application programmatically. It does require some investing and learning this programming language that's required to do it, but it'll pay off in the long run in terms of the amount of time saved by not having to use Management Console. We also have customers who just don't want to learn a programming language just to manage their infrastructure, and that's totally okay. So we offer AWS CloudFormation as a service that makes this much simpler. It is a domain-specific language, or a DSL, for describing cloud infrastructure. So what is this infrastructure as code with CloudFormation? Here's an example of a CloudFormation template. This template describes a description which says what the template does. It's a human-readable metadata about the template that says what your intention is. It's kind of like a comment in code. And then there's a section for resources. And in this section is where you list, in this particular example, we're creating a code commit repository and a Cloud9 environment. We see that we can reference one resource from another, as we see near the bottom with the repository URL that gets the attribute clone URL HTTP from the repo that we created in the previous section. This allows you to connect resources in a way that complies with your business logic as you're building your application. So the way this works is that you send this template to CloudFormation, and then the CloudFormation service, the AWS CloudFormation service, will translate that template into SDK or CLI calls as needed to actually provision that infrastructure for you. So CloudFormation service maintains the contract with the other AWS services about how to build and tear down specific resources. And then they separately maintain a contract with customers, an API contract with customers, saying how to define infrastructure in this very simple, like, narrow way. This allows customers to not have to think about each individual resource and what particular API operations it needs. Right. So we'll walk through an example of how this works. First, you create your template, much like the one that we just looked at in the previous slide. This describes our resources and parameters that it might need to customize the template. It could have outputs if you wanted to get some data out of it once it's done running. And then you send this to the CloudFormation service. Usually you would either upload it to S3, you could check it into code commit, you could check it into any kind of Git repository, have a continuous delivery pipeline that does some checks, which we'll discuss later, that check for correctness, or they might check for compliance with company policy. Once all those are good and it passes, then we give it to the CloudFormation service and say, please build this infrastructure. CloudFormation service will take a template and turn that into what's called a stack. And the stack is just a collection of the resources that are generated based on what the template defined. And then you can manage many stacks over time in CloudFormation. So you could have hundreds or thousands of stacks that each have tens or up to 200 resources apiece. And all these are managed in CloudFormation in one centralized place. So let's talk about some best practices when using AWS CloudFormation. First, we'll discuss kind of what each of the individual parts of CloudFormation are. And we'll start with a template. A template describes resources, attributes, and dependencies, and their intended state. We've already talked about templates a bit, but I just want to make sure that we're giving them a thorough treatment here. And these are the artifacts that you maintain in version. So you might check this in, and it will correspond to a specific commit in a Git repository. You might put this into S3 with versioning, and it's pinned to a specific S3 object version. But customers can build and define these any way that they want, and they can store and version them in whatever way is appropriate for their business. And then they can, once they have the template done and they're ready to have it turn into infrastructure, they can give it to the AWS CloudFormation service. CloudFormation service will take this template, and if we assume that the stack has already been created and you give it an updated template, what it'll do is it'll attempt to perform a difference between the two. I'll have to call it a diff. And this results in what's called a change set, which describes the execution plan to implement the intended state of the stack's resources. So if you had a template that included an S3 bucket, and then you send an update later with a new template that didn't include that bucket, it would see that diff showing no bucket, the second one, and this change set would say, hey, if I execute this template and this change set, this bucket will be deleted. Is that what you want? And you say, yes, that's exactly what I want. Go ahead and do it. Or you could say, no, that was a mistake. It must have been a typo. Cancel this, and your infrastructure is not at risk of being deleted. You can tell it to automatically approve these if you want to live dangerously and just say auto approve all the change sets. I would recommend you not do that, but it's something you might want to do. So once the change set's good, we say, yep, this is great. CloudFormation will turn this into a stack, which is just a group of resources and their intended states. The stack exists inside of the CloudFormation service as a way of representing all of these resources in a logical bundle. You don't have to maintain the state files of the state of your resources. That's maintained inside of CloudFormation. All you have to maintain is the CloudFormation template that was used previously. You could, if you really wanted to, throw away your template, and then if you wanted to update it, you could pull whatever's in CloudFormation back from it, copy it out, make your changes, and put it back. I wouldn't recommend people do that, but it is something we've seen people do, and it is possible if you don't want to maintain any kind of versioning on the template. And then many stacks can be combined in what's called a stack set. And these are convenient ways of distributing stacks across accounts or regions for medium to large organizations. So if you're a large company and you've got 20 or 30 AWS accounts and you want to deploy some base infrastructure to every one of these accounts, you could do it manually, go into each account and manually deploy these resources. But like using the console, that would get a bit tiring. Even if you automated it, there's still some parts that would make that difficult. CloudFormation allows you to say, here is a stack. I'd like this stack sent to all of these accounts. you can control, one account at a time, 2 accounts at a time, like the order and how quickly it rolls out to all of these accounts, so you can test to make sure this change is appropriate as it's deploying to your organization. So next we'll cover some of the best practices with templates. When you have a template, you could just send it to CloudFormation and then let CloudFormation tell you if there's an error. It can be rather time consuming because some resources depend on other resources and you can model this dependencies in your template. But if it takes a long time to create the resource, you hit an error, it's going to have to roll those back. You could waste a lot of time because there was an error that you didn't expect. So we offer these tools like CFNlint, which is available on GitHub. It's an open source tool that will check your CloudFormation template before it's deployed and tell you if there's any really obvious mistakes. So for example, in the template that we have here, we see that we picked up several warnings. This top level item called errors doesn't exist. It's not part of the specification. Some of these are missing properties that'll give you a warning about invalid instance types. All these things that we can check based on the specification or the schema for CloudFormation and say, hey, you said this, but I don't think it's quite right. There are cases where CFNlint just misses something, that you look up some property and the role that's used to look up the property doesn't have permission to actually do the lookup, and that'll fail. And there isn't a good way to check that pre-deployment time. But CFN will catch many of these bugs much sooner in your application development process and save you a lot of time. Next, talk about change sets. I briefly covered this just a moment ago, but we'll go into a bit more detail. So you've got some original stack template. And when you apply a new template to that, you say, hey, deploy this new template, apply it to the stack. CloudFormation will compare what's in the new template with what already exists and ask, what's the diff between these two, and then prompt you to either accept or reject the change set. You can tell it to automatically accept or to reject whatever's appropriate for that specific case. Let's assume that we say, yes, accept this, then CloudFormation will execute the change set. And that will turn the change set into an actual new resources. So it updates the state of your stack. And within your stack, there are ways of, when you're defining infrastructure, because it's a text file that you're passing around. In this example here, we have a database that has the master user password in it. We don't want this password just as a text file checked into our Git repository for anyone in the organization to see. Right? So a way that we can supply this without having to actually enter the password in manually is we call dynamic variables. So an example we have here, we're using the systems manager's secure strings to reference a value in systems manager that has a secure string that will pull it out at deploy time. So the way this works is that you supply the string that we described here, literally assuming that the name of it is this SSB RDS MEs. I'm not sure what that name is, but someone probably chose that for a reason. You say, okay, get the secret from here. And the CloudFormation service, acting on your behalf, will go and get that string and then supply it to the provider for the CloudFormation resource, the RDS service most likely. So the password is never logged anywhere. It's never saved. It's never printed. You don't have to worry about accidentally checking it into your Git or S3 or some other place where it might be leaked. So this is a very secure way to supply sensitive information to the description of your resources. This also happens with API keys if you're trying to interact with a third-party system. Basically, any kind of string could be represented in this way. So what people often ask is, how do I know what goes together in a template? Do I just fill one template until it hits 200 resources, and then I start a second template, and then fill that one until I go to another one? And the way I like to think about it is that the things that tend to change together, you want to put in the templates together. So if you have two resources that never change at the same time, they're not related in any way, they probably don't belong in the same template. So this is great because it prevents you from accidentally deleting something inadvertently or removing something not knowing how it's related or why it's related. It makes it easier to reason about kind of what each template does. And we've also seen people talk about, based on kind of what the template does, separating those out. So you've got identity and security will be a nice a base, kind of like building a wall. On top of that, you'll have networking resources like VPCs and NAT gateways. On top of that, you'll have monitoring resources that are monitoring your network and your IAM security footprint. And then building services, stateful, stateless services on top of that. So there's several ways to do this. We don't prescribe that customers do any specific way. We just give you the options to do it whatever way works best for you. And we also encourage the use of these stack sets, which I covered a moment ago, which allow you to define these target accounts in these groups. And you can say, take this template and apply it to this set of accounts, and then this set of accounts, and this set of accounts. You can do this across regions, across accounts, so you can keep your entire AWS infrastructure across your entire organization in sync and updated as appropriate. And then finally, we recommend using drift detection. So what drift detection does is it looks at the state that's defined in the template and the actual state of the resource. So it might do some SDK or CLI command behind the scenes to query that resource and say, hey, what kind of state are you in? What do you look like right now? And in a perfect world, it would match exactly what the CloudFormation template says. But if there is a difference, CloudFormation will highlight this to you and say, hey, you have drift detection turned on. And this thing, in this one, it's an EC2 instance, it appears to have drifted. So there's one part that has stayed the same. It looks like someone has removed the associate public IP address property. So if true is the default, it would have made a difference. If true wasn't the default, it's actually a change. And they've added this new delete termination, which they've set to false. So it looks like somebody attempted to try to delete this by setting the delete termination, delete on termination setting. So CloudFormation can tell you, hey, something's changed on this outside of CloudFormation, and I can't be certain that if I apply the next change set, it'll do what you think it'll do. And you can set it so that it'll stop the change set from executing in this case until the resource is brought back in line with what CloudFormation expects. And finally, let's talk about infrastructure as code with the CDK. When you're using CloudFormation, those templates, even though we showed were very small, they can become very, very verbose. A VPC requires about 300 lines of CloudFormation once you can configure all of the possible options for it. Most of the time, you don't really care about many of those options. The CIDR range that's used on your private subnet is generally of not too much importance, so much as it's the right size. If I have enough IP addresses, I really don't care what the first octet or the second octet looks like. So we'd like to give customers a way to not have to worry about that. And the way we do that with CDK is that we provide these abstractions. These abstractions are provided in a language that customers are already familiar with, potentially already familiar with, which we'll cover in just a moment, which languages those are. It also allows you, because you're using languages that you're already familiar with, you can use the same editing tools that you're already using for your code. So if you're using PyCharm for Python, or you're using VS Code for TypeScript or C# programming, you can reuse those, which give you your tab completion, type hints, static checking and linting and analysis of the code to make sure everything conforms to code editing standards that you have inside your organization. So we currently support Python, JavaScript, TypeScript, Java, and C#. And this allows you to reuse the same tools you already have. So if you're testing your application code that's written in Java with JUnit, you have a good, strong code coverage and testing infrastructure built up around that, you can reuse that same infrastructure for testing your infrastructure definitions, which would normally be in CloudFormation. And the way this does this is that the CDK will compile your CDK application down into CloudFormation. So it turns your application into CloudFormation for you, and then you can then send that to the CloudFormation service and let the CloudFormation service do the provisioning. So we'll quickly walk through kind of how this looks mechanically. The CDK is composed of what we call constructs, which are an application, stacks, resources. There's the CDK CLI, which is a client-side tool that runs that interacts with the constructs, but also interacts with CloudFormation or the CDK engine. The CDK CLI will output CloudFormation templates and assets that are used to support those templates, and the CLI will also deploy it to CloudFormation. So the three main parts of CDK are for the framework that we just discussed, this construct library, where there's a module for nearly every AWS service that says, here's a good abstracted way of thinking about these particular resources, as well as the CLI, which interacts with both the construct library, the core framework, and CloudFormation, and obviously the customer. So here's what some sample code for CDK looks like. This example is written in TypeScript. Someone can say they're creating an API here, so they're saying I want an API gateway, I want a REST API, and then later they can attach services, they can reference it, attach services to it, similar to how they would do in CloudFormation. So here in this example, they're attaching a health monitor construct to the endpoint URL for the previous API that they just created. And when you run this application, it will output CloudFormation that can then be deployed by the CloudFormation service on the other end. These two examples are the CDK code that's on one side isn't the code that would generate the CloudFormation on the right. These are just two examples, but it's just to demonstrate that you could take some CDK code, which is written in whatever your preferred language is. Here it just happens to be TypeScript, and you run CDK synth or CDK deploy, and it will generate and output actual proper CloudFormation for you. So you don't have to use like CFNlint or some CloudFormation specific tool to check to make sure that your CloudFormation code is accurate. So I've mentioned constructs a few times, and there's a few parts I want to identify just so we're all on the same page. We have L1 constructs. These represent the core CloudFormation resources. It's a one-to-one mapping. It looks just like the CloudFormation template, but in whatever language that you're using. So if the CloudFormation template requires a property, the L1 construct will require the same property. The CloudFormation doesn't have some resource, there won't be an L1 construct for it. It's just a plain one-to-one mapping between the two services. Next, on top of that, we've got what are called L2 constructs. These are the L1 constructs, but with many default values supplied, what we think are sensible defaults. So in the case of the VPC, there are many options you have to select, like 50 or 60 choices that you have to make when you're building this. So we've said, we think most people will probably be happy with 2 public, 2 private subnets, Class B, CIDR range on the private side, and some other we think are a good combination of it's flexible, it's secure, it's cheap, and so you can, in a single line, say, give me a new VPC. I don't care about anything else, and we'll supply default values for all the rest of it. And then you can kind of peel back some of this abstraction. So if you say, well, I want it in more than one availability zone, or I want it in exactly one availability zone. You can specify this as a property, but you don't have to specify everything else with it. You can just say, I want a VPC, but also I want this other thing. And then what we're starting to see more of lately are what we call L3 constructs. And these are opinionated reference architectures and design patterns that are building on multiple AWS services. The serverless is a very common case where these are used frequently, where someone will build a CDK L3 construct that is an API, a Lambda function, a DynamoDB table, and maybe SQSQ. And it's all stitched together and works to solve some specific use case. Maybe it's a static site, or maybe it's a voting application, or whatever someone thinks might be a good reusable component, but it spans across many different types of L2 constructs or many different AWS services. So here's an example of what's called a load-balanced Fargate service, application load-balanced Fargate service. So this is a Fargate service with an application load balancer in front of it, routing the traffic to the Fargate tasks. And the only thing that's required here is to give it the options, which is this container image from the ECR registry, and you give it a name. Right? So you can get an entire application built end-to-end, here we go, with just a few lines of, in this example, TypeScript. Java would probably be a bit more verbose. Python would probably be very similar to this. And in the example here, it shows that it's 800 lines of CloudFormation template, which is subnets, elastic IPs, you got security groups, IAM policies, ECS task definitions. And all this is just done for you as like a default. You can override any of these options if you wanted to make the security group more broad to have it interact with some other service. But we like to think that the only thing you have to do is the bare minimum, and then we will kind of figure out what's appropriate for all the other areas. So in summary, infrastructure as code makes managing cloud applications and resources more repeatable and safer because it's checked into a version control system that you can roll it back to a previous version if you need to. AWS provides multiple options for infrastructure as code, including CloudFormation and CDK. And ISC best practices can apply across AWS and non-AWS tools. CFNLint is a tool that, although we created it and it's open source, it's not an AWS product. Anyone can contribute to it. There are other tools that interact with the CloudFormation service or interact with our services that also provide infrastructure as code. CloudFormation just happens to be the tool that we provide and that we think really hits the mark for what customers are looking for. For more information, you can check out these links, the link to CloudFormation's documentation for CloudFormation, the CDK landing page. Our open source resources are on GitHub. There's AWS organization on GitHub, which lists kind of everything. And then there's also the GitHub organization for AWS Labs, which are experimental tools that we're creating, and the CloudFormation organization, which covers the resource provider framework that was just recently released. If you're interested in learning more about building modern applications on AWS, we have several resources that are available to you. We have free digital training and classroom offerings that include architecting on AWS, developing on AWS, and DevOps engineering on AWS, which cover the various aspects of the software development lifecycle when you're building on AWS, as well as the AWS Certified DevOps Professional or AWS Certified Developer Associate exams to validate expertise in building applications on AWS. And that is it. I want to thank you for attending today. I hope that you've learned something. I've enjoyed explaining this. Feel free to reach out to me, rhboyd@amazon.com, if you have any questions. Happy to answer them. Thank you.